When you think about human evolution, what pops into your head? Is it that really iconic image?
The straight line one, ape to human.
Exactly. That
Yeah.
simplified picture of a single figure sort of slowly standing up straighter, ape to modern human, like one clear path.
Right.
Well, if that's your picture, get ready for a bit of a shakeup because today we're diving deep into some, well, frankly, incredible science.
Really groundbreaking stuff.
Yeah, discoveries that are totally rewriting that story.
Our mission here is to unpack how our early ancestors weren't really on that simple track.
Mm-hmm.
It was much richer, way more complex. Scientists are now calling it a bushy tree of species.
That's a great way to put it. And the core of what we're looking at today, it comes from a key paper in Nature.
Okay.
And also a related report from researchers at Arizona State University. Both dig into these amazing fossil finds in Ethiopia.
Right, from that Ledi-Geraru site you mentioned.
Precisely, Ledi-Geraru. And what we're going to lay out for you in this deep dive is how these finds really paint this vibrant picture. Different ancient human relatives actually living side by side.
Sharing the same landscape millions of years ago. It's pretty mind-blowing.
It really is. It's like a shortcut to understanding this period that's just way more dynamic, more intricate than, most of us probably thought.
Definitely. So let's jump right into that main finding, the one that's really making waves.
Let's do it.
Scientists have found this really compelling fossil evidence in northeastern Ethiopia at Ledi-Geraru.
Okay.
And it shows that two distinct hominin lines, so species from the genus Australopithecus.
Like Lucy's relatives?
Kinda, yeah. Them and some of the earliest known members of our own genus, Homo, they actually coexisted.
Coexisted. So same place, same time.
Same place, same time. We're talking roughly between 2.6 and 2.8 million years ago.
Wow. That's huge, isn't it? I mean, it totally blows up that neat straight line idea from the textbooks.
It does. It shows evolution isn't that simple ladder. It's this complex, branching, bushy tree is the perfect term.
With lots of different forms, and, well, many of them just didn't make it right. They went extinct.
Exactly. There's a great quote from ASU paleoecologist Kaye Reed. She said, "This new research shows that the image many of us have of an ape to a Neanderthal to a modern human is not correct. Evolution doesn't work like that. Here we have two hominin species that are together. It just points to so much more diversity back then than we realized."
Much more than we previously understood.
Precisely. This idea of coexistence, it really challenges older assumptions, the ones that imagined a more sort of sequential one after the other appearance.
Right, like Australopithecus fades out, then Homo appears.
Yeah, and this shows it wasn't that clean cut. It forces us to rethink the origins of our own lineage.
So how do we actually know this? What's the proof? You mentioned fossils. It comes down to teeth.
Literally, yes. 13 hominin fossil teeth found at Ledi-Geraru.
13 teeth. And you might be sitting there thinking, okay, 13 tiny teeth. What can they possibly tell us?
It's amazing what they reveal. These specific teeth are so valuable because, well, they show both early Homo,
Our genus.
and a previously unknown species of Australopithecus,
Mm-hmm.
all in the same rough time frame and location.
Huh?
Now remember, Ledi-Geraru was already famous,
Yep.
right? It gave us that earliest known Homo jawbone back in 2013.
Oh, yeah, the 2.8 million-year-old one.
That's the one. And some of the earliest stone tools, Oldowan tools.
Right.
Brian Vilmore, one of the lead authors on the Nature paper, he said these new Homo teeth, quote, confirm the antiquity of our lineage. It adds more weight.
Okay, that makes sense.
Yeah.
But how do they know how old these tiny things are? Millions of years, that's mind-boggling. How precise can they be? Is it guesswork?
Oh, not at all. It's actually really robust geological science. You see, the Afar region in Ethiopia where they found these, it's an active rift zone. Lots of tectonic activity, volcanoes.
Oh, okay, volcanic activity.
Exactly. So when these ancient volcanoes erupted, they laid down layers of ash. And within that ash, there are these tiny crystals, feldspar.
Feldspars.
Okay. And these crystals contain radioactive isotopes. They decay at a known rate, like a natural clock, so scientists can date the ash layers very precisely.
Like a timestamp.
Exactly like a timestamp. And the geologist Christopher Camposano explains, the fossils themselves are found interbedded, basically sandwiched between these dated ash layers.
I see. So if you know the age of the layer above and the layer below...
You get a really precise age range for the fossil in between. It gives amazing age control. Another geologist, Ramon Arrowsmith, adds that the geology doesn't just give age, it tells us about the environment too, the type of sediments.
Fascinating.
And just to give you an idea, some key ash layers, our timestamps, are dated to around 2.78 million years ago, another about 2.63, another around 2.59 million years ago.
So really specific dates.
Very specific, and the fossils fit neatly within or between those layers.
Okay, so we've got these ancient teeth, incredibly well dated. Now, let's meet the residents, so to speak. Who are these species living together, and how could they tell them apart just from teeth? That must take some serious analysis.
Oh, absolutely. It's like forensic work, but on a million-year scale.
Yeah.
So first, the early Homo evidence.
Okay.
One key find was a lower premolar tooth, found in sediments dated to around that 2.78 million year mark.
Right, the older layer.
Yeah, and it was identified as Homo because its shape and features, they're more derived, and it just means more advanced, evolutionarily speaking.
Okay, different from the older guys.
Exactly, different from the pre-3.0 million year old Australopithecus species, and it matches other early Homo fossils from the area. Then there are other molar fragments found in slightly younger layers, maybe 2.59 million years old.
Uh-huh.
They also show those distinct Homo features, especially in the crown shape. Not enough to name a specific species like Homo habilis or whatever, but definitely Homo.
Just genus Homo,
Well, no.
species unknown for now.
Homo sapiens, exactly. Now, the really new thing is this Australopithecus.
The one they hadn't seen before.
Right. A collection of teeth from that middle layer, around 2.63 million years ago. Together, they point to a previously unknown species of Australopithecus.
Wow. A whole new species.
Well, potentially. They can't formally name it yet, just based on teeth. You really need more, like a skull or a more complete jaw.
Okay, need more evidence, but they know it's different.
Oh, yeah. It's clearly distinct from, say, Lucy's species, Australopithecus afarensis. For one, there's no sign of A. afarensis being around after about 2.95 million years ago.
So this one's younger.
Significantly younger. Plus, the teeth look different. Their lower molars are more square. They don't taper backwards like A. afarensis. And the wear patterns on the canines are different too.
Subtle but distinct differences.
Exactly. And it's also different from another species, Australopithecus gari, which lived around the same time.
Okay.
The Ledi-Geraru teeth don't have the same specific canine and upper molar shapes or the same kind of wear patterns seen in A. gari.
So clearly a third player on this.
A third player. And what's really significant here, this discovery, along with A. gari, it's basically the only solid evidence we have that the Australopithecus genus was still kicking around in East Africa after 2.95 million years ago.
We thought maybe they'd died out by then.
Well, the evidence was getting thin. This shows that lineage persisted longer, alongside early Homo.
So let's recap the diversity picture then. Between, say, 3.0 and 2.5 million years ago, just in this one region, the Afar.
You've got at least 3 distinct hominin lineages.
Yeah.
You've got early Homo, you've got Australopithecus gari, and now you have this new Ledi-Geraru Australopithecus.
3 groups, maybe bumping into each other.
Possibly. And that's just East Africa. Globally, around the same time, you have Australopithecus africanus down in South Africa.
Right.
And you see the emergence of the Paranthropus genus, the robust Australopithecines in places like Kenya, Tanzania, Ethiopia too. It just paints this picture of a really vibrant, really diverse, maybe even crowded evolutionary stage.
It really does. Makes you want to picture it, you know?
Yeah.
What was that world like? Can you set the scene? What kind of environment were they all sharing?
Yeah, absolutely. The landscape back then, 2.6 to 2.8 million years ago, it wasn't the dry, faulted badlands you see at Ledi-Geraru today.
Okay.
It was actually much more vegetated. Think migrating rivers, shallow lakes that would grow and shrink over time.
So wetter, more woodland maybe.
Probably a mix. Less open desert, more like a dynamic environment with access to water, plants, maybe woodlands near the water sources.
Interesting.
And here's a really intriguing twist, something that's sort of challenges an older idea.
Oh, what's that?
Well, for a long time, there was this theory that the appearance of our genus, Homo, was maybe linked to a shift towards drier, more open, savanna-like habitats.
Right, the savanna hypothesis kind of thing.
Exactly. But these findings, right, they suggest maybe not. Early Homo here is found in this more vegetated, wetter setting alongside Australopithecus.
So a more open habitat wasn't necessarily the trigger for Homo.
It doesn't seem to be uniquely associated with it here, no. Which, raises a whole bunch of new questions about how these different hominins were adapting. What were the environmental pressures driving change? It's not as simple as savanna appears, Homo appears.
Yeah, it leaves you with so many fascinating questions, doesn't it? Like, okay, they lived together, were early Homo and this unnamed Australopithecus eating the same things.
Good question. Were they competing?
Or did they specialize? Maybe Homo was using those early tools for something different.
Possibly. Did they carve out different niches? Or were they in direct competition for food, for space?
Did they, actually see each other? Did they interact on the landscape day to day?
We just don't know.
Yeah.
And who were their direct ancestors?
Yeah.
Where did this new Australopithecus come from? Where did this early Homo branch off? So many threads to pull on.
It really underscores that point you mentioned earlier from Kaye Reed.
Exactly. She said, whenever you have an exciting discovery, if you're a paleontologist, you always know that you need more information. You need more fossils.
Always more questions.
Always more questions. It just perfectly highlights how science works.
Mm-hmm.
Right? Every discovery opens up new avenues, new mysteries to solve.
Mm-hmm.
So yeah, this deep dive into Ledi-Geraru, it really hammers home the incredible and often really surprising diversity in our deep past.
Yeah.
It's a fantastic reminder that human evolution wasn't this straightforward linear march. It was complex, multifaceted.
Yeah.
A bushy tree again.
Not a ladder, definitely a dense, sprawling tree.
A forest even.
Yeah, and thinking about that forest, that picture of coexistence, all these different branches, and knowing that ultimately our branch, Homo, survived, diversified, and led to us, it makes you wonder, doesn't it? What was it about our lineage? Was it adaptability, ingenuity, tools, something else?
What allowed Homo to thrive while these other branches eventually, well, went extinct.
Exactly. What are the lessons there, buried deep in these ancient stories about adaptation, about survival, maybe even about what makes us human? Something to really mull over.